If we were a movie, I'd teach you physics. All right, let's do it. Beginning with the following equations, we're going to do whatever I'm telling you to do. That was not an inspiring, cry to get you into this problem, but nevertheless it is actually helpful that I'm giving you this problem, because I am going to make you come up with either the range, the height, or the time formula for a projectile. And let's just kind of review. I didn't even give you the picture, right? You should, though, in your mind have a picture like this in your head, okay, where we're launching at a speed v naught at an angle theta, and these are given. And then, of course, what we want to do is we want to get range, we want to get time. We don't even need to necessarily get height for this one. You know what? I should label that with an H for height. And then, of course, we have a time that we're in the air for. These are the three unknowns, and we want to get them in terms of v naught, theta, and g. And so let's actually follow the hints. Let's get the equation for hang time. So we know that Vy is negative gt plus Vy sub 0. You could use any formula you wanted. I'm just grabbing an easy formula that has time in it. So if you want to know my rationale, why did I pick that formula? Because it's easy and because it has time. And if I were wrong, I just used another formula that has time in it. So you notice I kind of took formula number 2, but then I modified it to suit my nefarious ends. Now, keeping this in mind, when we reach the very top of the trajectory, the speed in the y direction vanishes. We have negative gt plus v naught sine of theta. So half of the time, just the time to get up, is v naught sine theta over g. And so the total hang time is going to be double that. Sweet. Now for that's part A. And for part B, let's get the range formula. So we know that in the horizontal direction, x is going to be v naught cosine theta t plus x naught. That's just using the constant velocity formula in the x direction. There's no acceleration in the x. Everybody wants to throw in g for the acceleration. You're not. Think about it. G is for falling. It's not for traveling horizontally. So we have x is v naught cosine. Now the total time that we're traveling for in this horizontal direction is the entire hang time from there to there. So I'm going to use my hang time formula, 2 v naught sine theta over g. And then when I actually simplify this, I'm going to get x, my range, is v naught squared times 2 cosine theta sine theta divided by g. Now this formula here is actually a double angle formula from physics, or from math, so this is actually going to end up being v naught squared sine of 2 theta divided by g. So this is actually the range formula right here. So there's a lot of arguments you could do. One thing you could do, if you're a calculus nerd, okay, so this is the calculus approach, which is dr d theta equals 0. We want to prove that 45 degrees gives us maximum. And you could really prove it by taking the derivative and saying, okay, so I got v naught squared cosine of 2 theta times 2 over g, okay, equals dr d theta. And then what we realize is if theta equals 45, cosine of 2 theta equals 0, so we've maximized the function. But what's nice about this is even the lazy approach works, where you're like, oh, wait a minute, sine of 2 theta equals 1 max when theta's 45 degrees. Oh my gosh. And that's really all we need to show this. So it actually turns out you get the maximum horizontal range when there's no air resistance with an angle of 45 degrees. Whoa. Alrighty. So I hope that's helpful. That is problem number 2. Okay, and keep in mind, I realize these videos didn't take me the longest time to record. And don't gauge your time on the exam by my time to solve these. You will get to a point where you're solving these problems this quickly. It's September. The AP is in May. We're going to slowly but steadily, okay, and definitely rigorously get you ready for that exam.